Okay, so till now, what we have done is print some lines. But I can print a line without using C++, right? I mean, it doesn't seem that interesting. But don't worry, there is a lot to come. In just a few more videos, you will start visualizing the real power of C++. And data types is one of the first things you should know to start using the real power of C++. Before we talk about data types, let's talk about variables a little bit. So variables are a reserved memory location which stores some value. And every variable will have a data type. So when you define a variable, when you declare a variable, you tell the compiler that you need to reserve some memory for me and you need to store this value, but you also need to specify that the value I am storing at this location is of what type. Is it an integer? Is it a character? Is it a decimal number? What kind of value you are storing in that variable, and that is specified by data type. So there are 7 basic data types in C++, and they are booleans, characters, integers, floating points, double floating point, valueless, and wide character. So booleans store your true or false. So they are used in your results of logical calculations. Characters will store all your lowercase, uppercase characters, your digits, and all other special symbols you can see on your keyboard. Integers will store your integral values, and floating points will store values which have a decimal point also. Then there are double floating point. Double floating point will just have more precision than your floating point numbers. Then there is something called valueless, which is represented as void. So void is generally used with functions. So when you make functions, you return something out of that function. There are many functions which do not return anything. So the data type they are returning is void. Void would become more clear once we talk about functions. So don't worry about that right now. Then there is wide character. So your character will have space for only 256 characters. But there are many other non-English languages which contain many other symbols. So to store those symbols, your character, the space character has is too small. So a new data type wide character was developed to store all those values. So wide character is just a character which can store a large amount of symbols. Then there are modifiers. So modifiers are just used along with your basic data types and they modify their meaning. So there are modifiers like signed, unsigned, long and short. So if you use unsigned with say integer, then your integer can hold only 0 and positive values. It cannot have negative values. Then here is a table of the size and ranges of various data types. Just look around it a little bit. You notice that if you see the signed and unsigned version of any data type, for example, character, their sizes are same, 1 byte. The difference which arises is in their range. And if you look at long and short, for example, in integer, you will see difference in their sizes also and ranges also. Now, you can notice things about characters like characters have ranges in integers. So in C++, characters are used like integers. All of your characters have some ASCII value associated with it, American Standard Code of Information Interchange, that is the full form of ASCII. And so all your characters are represented by ASCII symbols, and these ASCII symbols are actually integers. So your characters are stored as integers, which are converted to binary form, and then they are stored in your memory. So that is why you will see the range in integral values. Then you will see that characters also are signed and unsigned. That doesn't seem so meaningful, but they are there because characters are actually a type of integers also. They are implemented like integers only using their ASCII codes. So that is why they are signed and unsigned. Then there are some other data types, which is derived data types and user defined data types. We'll discuss more about these data types later on, but just to name, there are various derived data types like arrays, functions, pointers, and references, and there are many other user defined data types too: structures, unions, classes, and enumeration. Now, we just talked about the sizes and ranges of data types, but the size and range of data types are dependent upon the computer you are using, the compiler you are using. So let's discuss about a way by which you can find out the size of the data type you are using. So let's switch to code blocks, and here I have made a project named data types, and in this I have changed the cout statement. I have written size of a floating number is. So I'm trying to print the size of floating point on my system, and then I have used a function size of. So this function tells me the size of anything which you pass in as argument. Here I am passing the data type float. Anything you write within the parenthesis of a function, that is the argument for that function. So this function is basically telling me the size of a floating point. And notice that I have not enclosed size of float within double quotes because I don't need to print size of float as it is. I need to print the value it is giving me, and I need to separate the string which is to be printed as it is, and your function calls or your variables with two less than signs. So I use this here. Let's try to run it. So you see size of floating number is 4. Let's try with something else. Maybe I'll say size of a boolean, and I'll change it to bool here. Let's see the output. So it says size of boolean is 1. So size of function is giving the answer in bytes. It's 1 byte for boolean, 4 bytes for floating point. You can try with different data types. You can try combining modifiers with your data types and finding out the sizes.